Hi everyone, today's lesson is on sinusoidal graph translations and their equations. So basically we're going to be graphing sine and cosine graphs and also translating them in addition to trying to find the equations for a sine and cosine graph, which is called a sinusoid. So let's get started. Okay, so the first one, what we have here is a sinusoid. Y equals 4 plus sine 3 times the quantity x minus pi over 6 plus 2. In the previous two videos, we talked about VAF, V-A-F-H-P, VAF translations, where the vertical shift was this value here, amplitude, frequency, and horizontal shift. So I like to put these values here. So V-A-F-H-P, VAF. And when you're doing these, you're going to plug these in. Vertical shift is 2. Your amplitude is 4. Your frequency is 3. Your horizontal shift going the opposite direction is going to be right pi over 6. And your period, because you're in radians, is going to be 2 pi divided by my frequency, which means that my period is going to be 2 pi divided by 3. So that means that the time it takes for me to start my graph and go through and finish it is 2 pi over 3. So we're going to start with our parent graph, which is just the sine wave. So we're going to start at 0 and sine ends at 0. Halfway through, we go through 0 at pi. Halfway through that, we have a high point, and then at 1, pi over 2, 1, and then halfway through that, we have a low point. So my sine wave does do this right here. Okay. The first thing I'm going to do is my vertical shift. So that means that my new axis is shifted up. So this was my axis here, but now I'm going to shift it up too, so that I'm going to draw a new sinusoidal axis, which is x prime. And then I'm going to draw my new graph again. Starts at 0, goes through 0 at pi, 0 there, goes halfway through here and here. So we go up 1, down 1, and it ends just like that. Now that's my vertical shift. So we did that. Now my amplitude being 4. Now remember, the amplitude is the height from my axis, from my sinusoid, not this axis. You are not using this axis anymore. Your graph is shifted up too. So this is the new axis right here. So your amplitude is 4. That means this distance here, this was 1, is now going to be 4. So that's going to be 1, 2, 3, 4. 4 up. 0 times that is still 0, 0. 1, 2, 3, down 4 here, ending at 4. So that means that my graph is going to go up, down, and end. Oops. Oh, I'm going to redraw that. It's going to go up, down. So I'm going to, let's see here, delete that. It's going to go, let's do this again. It's going to go up and over, go down and around, and then there. So my amplitude is done, meaning this distance right here, that's 4. This distance here is 4. And same with down here. 4 is, remember, an amplitude is always absolute value. That distance is positive, okay? My frequency is 3. Now, while I don't graph a frequency, I do graph the period, which is 2 pi over 3. So that tells me that my graph is going to start and end at 2 pi over 3. So there's pi. So 2 pi over 3 is about here, maybe a little bit more to the right, okay? So now what that means is half of that, so pi over 3, okay? So 2 pi over 3, I've got pi over 3. My graph is going to go up, come down, and end, just like that. And if you were to graph the frequency, what that means is you would do this 3 times in a 2 pi period. So that's like 1, there would be 2, and then you would do it 3. So, but for the case of this, I'm going to move this away. And the reason is because we still have to find the horizontal shift. So we have to take our graph right pi over 6. So now everything is shifted to the right. So instead of starting at 0, I'm actually starting at pi over 6. Instead of going through here at pi over 3, because remember that's 2 pi over 3, so that would be 1 pi over 3. I'm moving it pi over 6 over. So meaning if this ends at 2 pi over 3, where am I actually ending if I add pi over 6? Well, let's get a common denominator, and we've got 4 plus 1, which is 5 pi over 6. So I'm actually, instead of ending at 2 pi over 3, I'm ending at 5 pi over 6. So really, and half of that goes up, comes down, and ends. And again, as I said in the previous videos, I really want to see a highlighter or something. This should be on the black line here, just to show what it is. It's just a little bit easier to show where the graph is, etc. Also, please make sure you put your critical points in. So like this point right here is over 5 pi over 6, but then remember it's up 2, 2, like that. So make sure you put in all of your critical points. We're going to expect you to add in at least 3 or 4 critical points for each graph. So for this graph right here, again, let's do our VAF. So we have vertical shift, amplitude, frequency, horizontal shift. So I like to put everything on the side. So VAF is my vertical shift is down 5, so that's a -5. My amplitude is 3. My frequency is 4. So I'm going to see 4 complete cycles of my sine wave in a 2 pi period. My horizontal shift is going to be left pi over 2. And what am I left with? My period, it is in radians, so it's going to be 2 pi over my frequency, which is just going to be pi over 2, which basically means the entire graph is going to happen in pi over 2. So I'm going to start with my regular sine wave. So here's my regular sine wave. We call that a parent function. So it's going to be up, down, and end. My vertical shift is -5. So 1, 2, 3, 4. Let's drop this down. 5. So my new sinusoidal axis, which is x prime, is right there. My wave, I'm going to put my parent function right back on here. Okay. And then what I have now, okay, I did my vertical shift. I need to do my amplitude now, which is up 3. So 1, 2, 3, and still 0 times 3 is 0, 0, 0. It's going to drop down 1, 2, 3. It's going to go up. It's going to go down, and it's going to end here. Okay. So now we don't really graph a frequency, but we do graph our period, which is pi over 2. Now I do know this is pi, which means this right here is pi over 2. So what that means is that my graph is going to start and stop at pi over 2. And what you need to remember about a sine wave is a sine wave starts and stops at 0, okay? Halfway in between it goes through 0. Halfway in between that you have a high point and then a low point. So if my graph starts and stops at pi over 2, it is going to go through at pi over 4. In addition to that, it in between pi 0 and pi over 4, which is going to be pi over 8, I'm going to have my high point, and then I'm also going to have my low value in between. So it's going to go up, come down, and graph. And so right now, that's my graph, not forgetting that you still have to shift your entire graph over to the left, pi over 2. So that means it's going to start over here at negative pi over 2, right? This is my value, negative pi over 2. This value here will be negative pi over 4. This value here is still 0. So that's my final graph. And again, please remember to put in your critical points and label. Okay? Oh, good. Cosine wave. So put your VAF in. So we have vertical shift, amplitude is 3. Frequency, that happens in between the word and your variable. So that's going to be my frequency. And I've got my horizontal shift. So we have vertical shift, VA, F, H, P. vertical shift, amplitude, frequency, horizontal shift, and period. So my vertical shift is up 1, amplitude is 3. It is a 3. Amplitude is a height, it's a distance. I'm not forgetting that I have a negative sign out front. It does tell me that when I'm all done, I am going to reflect my graph over my x-axis, but I'm just going to ignore that for right now. Horizontal shift is going to be right, pi over 2, and my period is going to be 2 pi over my frequency, which is 1, which is just 2 pi. So I'm going to put my parent function in, which is my cosine. It's going to start at 0, 1. So cosine graphs, remember, start high, end high. Halfway in between, we have a low point. And then you've got these values here that kind of, remember, they look like a V, but it is a cosine wave, so it is going to have a lot of little wave going on there, okay? I have a vertical shift of 1, which means that my new sinusoidal axis is up 1. So this is x prime, okay? So that's my new axis. I'm going to redraw my graph, which starts high, ends high. Halfway in between, I have a low point. I cross the axis at 0. So now my graph does this, okay? So that's just the parent function, but I've been shifted up 1 unit. Now my amplitude is 3. So what that means is that the distance from my sinusoidal axis to the high point, my maximum, is 3. So that means that, remember, it goes up 1, so 2, 3. So this is my high point. Let me use a different color. So here's my high point. Still goes through 0. 0 times 3 is still 0. Down 1, 2, 3. 0. And then 1, 2, up 3. So this graph now does this. Goes down, comes back up, and ends. Okay, check. Amplitude, done. Now remember, we don't graph our frequency, but we do graph the period, which is in 2 pi period. So if you notice, the time it takes for me to start my graph, go down, finish my graph, it's a 2 pi period. Now the last part is that I do have a horizontal shift right pi over 2. So what that means is when it's all said and done, everything is shifted to the right pi over 2. So this was 0, 1, 2, 3, 4. So now pi over 2 over, so this point here is going to be pi over 2 comma 4. So there's that point. And then this point, which is at pi over 2, 1, is shifted pi over 2 over. So now this point is at pi 1. So it does help as you're going through if you like put your critical points in right then. So shifting this over, this was at pi, so now it's going to be at 3 pi over 2 comma, what is that? Negative 1, 2, okay? And etc. So this graph, let's see, where's purple? Shifting over 1, shifting over pi over 2. So my new wave is going to look like this, go down, come back up, and end. And again, I do want to just stress that I do like to see you having a highlighter or something just to kind of distinguish, there's my final wave. That's it. Put in all your points. Remember, that's super important. And what is this point? This looks like it's 5 pi over 2, comma, let's see, how far up am I? Oh, 4. Okay. Okay, so just make sure you put in your critical points. It's very, very important. So today, what today's all about, that was just a warm-up and review of your sinusoidal translations. But today what I want to do is I want you to come up with equations. So I'm going to give you a graph, and you need to come up with an equation and your VAF, what I explained to you earlier, which was your VAFHP, that's going to be super helpful. Okay, so I always, every time I do these, I list my VAF. So vertical shift, V, A, F, H, and P. And so, like I said, so our main objective here is to write an equation for this graph. What I want to stress also is that every one of my graphs can be, or any one of my sine or cosine graphs, my sinusoidals, can be either a sine wave or a cosine. It could be either. So you just have to decide, what you're trying to make it. Okay. So for example, if I want this to be a positive positive sine wave, okay? You're going to look at this and you're like, okay, what are my characteristics of sine? Remember sine starts at 0, ends at 0, right? Well, which one of these ends starts at 0? This one. It starts at 0, goes up, down, ends at 0. That's a sine wave. Well, I could do that. And that would be totally fine if I shifted to the right pi over 2. But in addition to that, I could make this graph a cosine wave. See that? Starts high. Even though I can't see it, I know it's going to end high, right? So that could be a positive cosine wave. Or I could shift this over here and guess what? Make it a negative cosine wave. So you have a lot of options. And so we're going to talk about that. That's like what today is all about. So let's do this. Okay, so I'm going to start off with making this a positive sine wave. And to make my vertical shift, you need to find the average between your high and your low points, okay? So my high point's 2, my low point is -2. This one's super easy, but I'm just going to go through the motions with this. You're going to find the average, the high point 2 plus the low point -2, okay, divided by 2. So what is that? 0 divided by 2, which is 0. So my vertical shift is 0, meaning I don't have a vertical shift, okay? Now, from here, my amplitude is this height right here. So 1, 2. So my amplitude's 2. Now, my frequency is the length it takes. We're going to do this last, okay? This is going to help us to do this last. But basically, my frequency is how many of these graphs do I have in a 2 pi period, okay? So what you're looking for is like low to low or high to high. So meaning if a sine wave starts at 0, see like right here, starts at 0, ends at 0, well, how do I know that period? So like I could go 5 pi over 2 minus pi over 2, okay, is going to give me 4 pi over 2, which is 2 pi. And what that's doing is it's telling me that from start to finish, see here, the difference between these two, that's my range, right? My range is my period pretty much. And that's what that's giving me. So let me fix that. Let me write that a little bit better so you can see that. So my period is going to be 5 pi over 2 minus pi over 2, which makes 4 pi over 2, which is 2 pi. So my period is 2 pi. Well, remember, a regular period for a sine and cosine wave is 2 pi. So that means I just have one of my graphs within that 2 pi period. Now, the last thing you need to worry about is your horizontal shift, meaning you are shifted off the x-axis. Remember, sine starts at 0, ends at 0, right? But because my graph is shifted off of the x-axis, then that means that I need to start here at 0. Well, where am I? I'm at pi over 2. So I actually went right pi over 2. All right. So now for my positive sine wave, I'm going to go y equals VAF. It's the VAFHP. So VAFH. So vertical shift, no vertical shift. Amplitude, 2. And my amplitude is connected to my word. So that's sine. My frequency is in between sine and my variable, which is, in this case, it's pi. It's a radian, so we're going to go x. If I'm going to the right, it's going to be minus, and then pi over 2. So this is the graph of my positive sine wave. So I'm done. Now, just for fun, let's make this into a cosine wave, okay? So making this into a cosine wave, remember, cosine starts high, ends high. I don't even care where it ends over here because I know where it starts and I know my frequency is 1 and my period is 2 pi. So that means that a positive cosine graph, okay, would be y is equal to 2 cosine. Now this is where it changes. My shift is going to change, x minus pi, because the cosine starts at pi. Now remember, if I wanted a negative cosine graph, okay, negative cosine graph, I'm going to do this. Watch. Y equals, oh, I didn't flip my last graph. negative, okay, let me think about this one real quick for just a minute. Y equals negative. See this negative sign right here? See that? Negative. So that's negative 2 cosine of x. And lastly, my negative sine wave, okay, is going to be y equals negative. Let's see, sine would go down first. So that would be all the way here. So it'd be negative 2, sorry about that, sine, negative 2 sine, let's see here, going down. Well, I just lost my train of thought. Okay, so x minus 3 pi over 2. Oh, I can't believe I forgot that. Okay, I'm going back to this last graph because see this a here? I totally forgot to flip it. So remember this, you had to flip this across the x-axis. See, this is my x-axis right here. So when you flip that across that, instead of it being up here at pi over 2, 4, it's down here, okay? And then still going through here, my high point's up here, my low points, my crossing my x-axis, and my low point is here. So it actually is doing this, and that's my final graph. Oh, and so that's this graph here. That is not my highlighted version, and my highlighted version is actually going to be this blue that goes up, comes down, and ends, because that's the negative. Completely forgot that. All right. Okay, so I hope you caught that, okay? I know you're probably like yelling at the screen going, go back, go back. Okay, anyway. All right, so let's start with this graph here. So write the equation of this wave right here. Did I just do that? I feel like, no. Okay, so it's a little bit different. Put your VAF, so get off highlighting. Okay, so we have V, F, AVA, F, H, P. Okay, so my vertical shift doesn't look like I have any. This is also very similar to the other one, 0 vertical shift, but my amplitude, again, is 2. My frequency, 0 to 2 pi, 1. Horizontal shift, none for a negative sine wave, and that means my period's 2 pi. So for a negative sine wave, we're going to go y equals my vertical shift, none, plus my amplitude. Oh, but see this? If I make this sine, see how sine, your normal sine wave, you guys, goes up, down, and ends. But this one is going to go down, up, and over. So that means it's flipped. So that's negative 2 sine. Frequency is 1. I can put a 1 here, or I can not put a 1 there. I have no horizontal shift, so it's just x. Done. But if I want to make this, let's say, a negative cosine graph, I'm going to shift it to the right, pi over 2. So that's going to be y equals negative cosine 2. Fix that. So negative 2 cosine. Okay. Let's fix that. So that's going to be y equals negative 2 cosine of, let's see, quantity x minus pi over 2. Now, if I want this to be a positive sine wave, I actually have to shift this all the way to pi, meaning y is equal to 2 sine, parenthesis, x minus pi. And then that actually is where I'm starting, going up and over. Okay, cool. Next, so to find this equation, we're going to go do our VAF. So V, A, F, H, P. Okay. Couple things. I noticed that my graph is all, these are numbers here. So I'm thinking that let's find our vertical shift first. So remember how to find that? We have to find the average. So we're going to go 5 is the highest, negative 15 is the lowest. So it's going to be 5 plus negative 15 divided by 2. So what is that? Negative 10 divided by 2, which is negative 5. So my vertical shift is negative 5, which means that this right here is my new sinusoidal axis, which means that my amplitude is going to be this distance here. So that'll be 5. So from here to here, so what is that? 5 minus negative 5. It's a difference. So 5 minus negative 5 is 5 plus 5, which is 10. So my amplitude is 10. Leave your frequency to the end. My horizontal shift, if I make this a positive sine wave, it starts at 0, I have no shift. So that means going up, comes down, and it ends right here. Now, just so you know, this is in radians, which means that this is about 6.28. And I know that because it's a little bit after 6. This means this is 2 pi. That's what that means. And that's pi. Because remember, pi is 3.14, right? This point here is 3.14. Well, 2 of those is 6.28. And that sure looks like it's right in between there. Okay. So it means it looks like I have one graph here. My horizontal shift, none. My period, 2 pi. So this graph isn't awful. This one is just y equals my vertical shift plus my amplitude, sine, frequency, x minus h. So let's put our values in. Vertical shift is -5 plus my amplitude, which is 10. Sine, my frequency is just 1. I don't need a number there. And then I don't have a shift. So it's like x minus 0, which I don't need a 0. I don't need to say that. So I could just say it's x. Okay, and I'm done. If I wanted to shift this to be a positive cosine, I would be shifting it over pi over 2, which is what? Half of 3.14, which is about 1.57. So I could do that. I could go y equals -5 plus positive cosine, 10 cosine, parenthesis, shifting it to the right. So x minus pi over 2, you could say x minus 1.57. Okay. Now this one, I'm asking you to graph 4 of these, okay? So for this, let's try to find our VAF. So VA, F, H, P. Vertical shift, okay, so we're gonna go, what is that number? 8. So we're gonna go 8 plus 0 divided by 2, which is 4. So my vertical shift is 4. So that means this graph goes from here, that's my new sinusoidal axis, which means that the difference from here to here, 8 minus 4, or 4 minus 8, absolute value of 4 minus 8, right? So absolute value is going to be, what is it? 4. So my amplitude is also 4. I'm going to ignore my frequency till last. Okay, my horizontal shift, I'm going to try to make this a sine wave first, and that's 0 to 0. So this is where I'm ending. Where am I? I'm at pi, which means that's pi over 2. Okay, so my frequency, horizontal shift, none if it's a sine. My period is 2 pi over my frequency. Now, this is the way you do this. You notice that the period, the time it takes to start and stop, is pi. So really, you go pi is equal to 2 pi over my frequency. See this? I'm going to cross multiply. I'm going to go pi times my frequency equals 2 pi. I'm going to divide by pi, okay? Divide by pi, and I get my frequency equals 2. Well, you probably already knew that. It means that I'm going to have 2 complete cycles, see? Starting at 0, going up, go down, end. That's 1. Up, down, end. That's 2 in a 2 pi period. That's 2 complete graphs. But I want to know, how long does it take to finish one cycle? Well, it only takes pi. Okay, so that's why pi is my period. But I don't put that in. That's my frequency is 2. Okay, so putting it into a positive sine wave, you're going to go y equals my vertical shift plus, remember, it goes like this. Y equals vertical shift plus my amplitude, sine, frequency times x minus h. So my vertical shift plus 4 sine, let's see, up, down, 4 of those. How many do I have? 2, and then x, okay? A negative sine wave is going to start at pi over 2 and then go down first, go up, and then end like that. So a negative sine wave is going to go y equals 4 minus 4 sine of 2x, okay? A positive cosine, I could either start here or I could start here. That's up to you, totally up to you. I could start here, and that's at pi over 4. So a positive cosine is going to go y equals 4 plus 4. All of these are the same except for the shift. Positive is going to be positive. So it's going to be cosine of 2. Did I forget to shift my graph over? Hold on. Negative sign. So down here, yep, I did. So parenthesis x minus, that was pi over 2. All right. Now for cosine, I'm starting at pi over 4. So 2 parenthesis x minus pi over 4. And a negative cosine, I could start negative, but I can't see it there. So I'm going to start here, which looks like it's 3 pi over 4, because that'll be a negative, right? Starting here. So y equals 4 minus 4 sine, no, cosine, hold on. Cosine 2, parenthesis, x minus 3 pi over 4. Okay, cool. All right, so here we go again. V, A, F, H, P. So vertical shift, my high point is 3, find the average, plus my low point looks like it's -9. So -9 divided by 2. So what is that? 3 minus 9 is -6. -6 divided by 2 is -3. So that's my vertical shift. So go to -3, put your line in, that's your new sinusoid. So from here to here, what is that? 3 plus 3, 6. So my amplitude is 6. I'm going to ignore my frequency for right now. I'm going to look at the time it takes for me to start and stop my graph. So if this is 0, and where am I? 2 pi. So it starts high, comes down, goes back up, and it ends high. That's a cosine wave, 2 pi. So that means that I have only one graph. My period's 2 pi, and I don't even have a shift. So my graph for a positive cosine wave is y equals vertical shift plus my amplitude, cosine, frequency, 1. So parenthesis, x minus 0, or just x. Now there's my positive cosine wave. So if I want to do, let's just have some fun and make this a, well, we know that's pi. So this is half pi. Let's make it a negative cosine. So that would be a negative sine. So y equals -3 minus 6 sine. And we're moving it to the right, what, pi over 2? A couple of things I do want to just remind you. You guys, you see these numbers, these are all the same, okay? The amplitude's going to be the same, that's this value. The vertical shift is always going to be the same. So like even if I made this a negative cosine graph, so watch, y equals vertical shift. A negative cosine is going to be minus, still number 6. Cosine, and then, so to make it a negative cosine, it would be negative here, right? Starting low, ending low. So that would be x minus pi. But the point is that the amplitude and the vertical shift are, and the frequency, if it was other than 1, 2, would be all the same value, even if you shift, okay? So this one, let's look at our vertical shift. So this looks like 5, right? And low -3. So I'm going to do the VAF. So V, A, F, H, and P. So my vertical shift, I'm going to go -5 plus -3 divided by 2. So that's -8 divided by 2, which is -4. So my vertical shift is -4. Then, and hold on. That's not right. Let's do that again. Dun, dun, dun. This is +5. Okay, so this is 5 and -3. So we go 5 plus -3 divided by 2. So that's 2 divided by 2, which is 1. So my vertical shift looks like right here, which is x prime, and it's 1. Okay, now my amplitude is this distance from here to here. And so that's going to be 4. Okay, so it's 5 minus 1, right? 5, absolute value of 5 minus 1, which is 4. So that is my amplitude. Ignore your frequency for right now. That's last. Now, let's figure out what kind of graph it. We're going to make this a positive sine wave. So we have to shift all the way over to here. And what is that? That is a positive sine wave. So that means that that's pi over 2. So this must be 3/4 pi, 3 pi over 2. Okay, no, 3/4 pi. So for a sine wave, that's going to be to the right, 3 pi over 4. Okay, but that's going to change as I shift the different graphs. Okay, my period. Now, this is the tricky part. I need either high to high or low to low, or I need a half, meaning, let's see, this, let's go from high to high. So here we are at a high point, and where am I? Where is this? This is in between negative pi over 2. This looks like negative 3/4 pi. Okay, so the distance from here to here, keep going, we got to go all the way to here. See the high point to the high point? That's where I'm going. So the distance from here to here is 3 pi over 4, right? And the distance from here to here is pi plus this value, which is 1.5. So what's in between pi and 3 pi over 2? So that, see, look what I'm looking for is this, pi and 3 pi over 2. So I'm looking for this distance in between. So that's 1, right? 1 and a fourth. Well, 1 and 1/4 is 5/4. So the distance from here to here is 3/4. The distance from here to here is 1 and 1/4. So plus 5/4 pi. So that's 8/4 pi. 8/4 pi is 2 pi. So that means my period's 2 pi, which means that my frequency is just 1. So a positive sine wave is going to put your whole graph together. Remember, it's y is equal to v plus a, sine or cosine, f times the quantity x minus the horizontal shift. And remember, some people call this a phase shift. Okay, so vertical shift is 1. So we're going to go 1, we're going to go y equals 1 plus my amplitude is 4, sine, frequency is 1. So we're going to go, did I shift it? Yep, we're shifting it to the right, x minus 3 pi over 4. Done. Now this one is a negative sine wave, and so to get a negative sine wave, I got to go down first. So that's from here. So this looks like it's negative pi over 2 here. So that means that's half of that. So that's negative pi over 4. So my same graph, so I'm going to go y is equal to 1 minus 4 sine x plus pi over 4. Let's see, a positive cosine function is going to start here, right? And or I could start here. Let's start here. Okay, so that's where I'm at. So we're going to go y is equal to 1 plus 4 cosine x. I'm going to go backwards, so that's going to be plus, right? And how far am I going backwards? 3/4. So minus 3/4. Yeah. Okay. And then lastly, that's a positive sign. Go to the right 3/4. That was, okay. And then where am we at? Last one, cosine. So we have y equals the, what do I want? A negative cosine. So that's going to be right here. So that'll be y equals 1 minus 4 cosine. And this will be an x minus half of the distance from 0 to pi over 2 is pi over 4. So, boy, that's a lot of information. Okay, so I hope that helps. Tomorrow, the next lesson that we start on is going to be dealing with trig functions that are the reciprocal functions. So like tangent, cosecant, and secant. Okay, well, I hope that helps you graph, and I'll see you next time. Thanks.